Hello, everybody. Welcome back to our session. So we are directly moving to the next talk. Our next talk will be given by Dr. M. Shahidul Islam. Before his talk, let me take this opportunity to introduce our resource person. Dr. M. Shahidul Islam is a professor of physical geography in the Department of Geography and Environment, University of Dhaka. Under a Commonwealth scholarship, he received his PhD degree from the University of St. Andrews, UK in 1996. He was the founding chairman of the Department of Geography and Environmental Studies of Chittagong University. He was also the Dean of the Faculty of Sciences of Jagannath University. Dr. Islam was also a visiting professor of Nagoya University, Japan in 2006. He has 6 books and about 75 research publications to his credit, including many in international journals. His research interests are on physical geography, geomorphology, quaternary environment, sea level change, coastal environment, and physical oceanography. Dr. Islam is currently the General Secretary of Bangladesh Association of Commonwealth Scholars and Fellows. He was also the Secretary of the International Union for Quaternary Research Commission on Sea Level Change and Coastal Evolution of Indian Ocean region. He is a life member of National Oceanographic and Maritime Institutions of Bangladesh and Bangladesh Geographic Society. Dr. Islam is a member of International Geographical Union on Coastal Commission. And today he will be giving a talk on sea level changes along Bangladesh coast, how much to blame global climate change. With immense pleasure, I invite Dr. M. Shahidul Islam for the talk. Over to you, sir.
The slides are visible.
Yes, sir, it is visible.
And the voice audible. It's okay?
Yes, sir. Yes, sir.
Okay, thank you very much, the organizers, for inviting me for this wonderful international colloquium. So I personally remember today that many years back, I visited Madras and Trivandrum and Tanjavur University, and I remember Professor Rajamanikam, who made it possible for me to make my first visit to your part of the country. And I express my sincere thanks to Suresh Gandhi, who I know for many, many years since my first visit. And thank also other member, particularly Dr. Tharun, who continuously kept contact with me since he started the process. So I express my sincere thanks to all of you. And you have seen that the title of my presentation is basically the presentation is, just hang on a minute. I would request somebody to keep the video off. It's making me some sort of visible problem. Okay, thank you. And the title of the presentation is, you can see the sea level changes along Bangladesh coast. How much to blame global climate change? If I had a second opportunity to change the title, I should rather say sea level change along Bangladesh coast, how much to blame human intervention. But I carefully keep this climate change word because the theme of the conference is some sort of link with climate change. That is why I had to keep this word climate change. Well, I'm very much impressed by two previous presentations, particularly the second one, and it has mentioned so many evidential argument that how climate change, global process, geological process, particularly in the long time context, are important, referring Milankovitch theories and other things. So I know that this is a forum of geologists. Many of, I think most of you are geologists. I am not a hardline geologist. I am a physical geographer. So I can say I'm not as hard as a geologist, but as not soft as a sociologist. I am some sort of breeze between human process and natural process. So from that context, I like to give some of my experiences so far I learned during the last 3-4 decades. So this is a short outline of my talk, is a outline, an introduction to Bangladesh, principles of sea level movement and sea level change along Bangladesh coast, and finally discussion. Part 1 and 2, I just could exclude from the talk, but I know most of the audience are here international. So many of you may not have any idea about Bangladesh geology, geomorphology. So I'll just give some brief account so that you get familiar with the system. And the second, I come to know from the organizer, the vast majority of the participants are from the students, research students. So to make this field familiar to them, I know already many of them are familiar. I'm just giving some of the basic principle of sea level science. And then I'm going to the details of sea level change of Bangladesh. Those who are really not familiar with Bangladesh, just few quick understanding that it's a very small country, 148,000 square kilometer, but very highly densely populated, 163 million, and the population density is more than 1,200 per square kilometer. The entire country is more or less a flat land, except few tertiary hills in this part. This is a tertiary hill and some Pleistocene terraces here and the middle. Otherwise, the entire country is the flat plain of recent origin. So if you see, there may not be many very radical change in physiographic condition if you travel along the country. But the country can be divided into 14 physiographic units. The famous geographer, British geographer, who spent 27 years in Bangladesh and worked very closely with the entire system, he divided Bangladesh into 12 physiographic units, and 4 of those units are in the coastal belt. That is the Ganges tidal floodplain. This part, this is southwestern part, Ganges tidal floodplain, and then the lower Meghna floodplain. This is the lower Meghna floodplain, and the Meghna estuarian floodplain. This is the estuary, and the last one is the Chittagong coastal belts. This is the coastal belt, and there are more than 700 years, 700 rivers are flowing through the country, but many of them are now been either filled or destroyed or lost their flow. But 53 to 57 are from the major rivers are transboundary, and Ganges, Brahmaputra, Meghna, Tista are the major rivers. This is Ganges coming through the northwest, and this is Brahmaputra, and this is the Meghna. This is 3 major rivers, and this is the Meghna estuary. And another river, this is the Tista, this is the Tista river, and the Garai Madhumati. So in my presentation, these rivers might come frequently: the Ganges, Brahmaputra, Tista, and Garai Madhumati. And if we go to the coastal part, the coastal belt is this part of the area is coast. It is very difficult to define the coastal region of Bangladesh. However, we have an operational definition, that is the 3-meter contour line. If we go to the 3-meter contour line, this is the 3-meter contour line, it covers nearly 20% of the nation, of the country, and 28% of total population, thus living into this coastal belt. So I am giving further details of the coast. This is the coastal belt. I say, why 3-meter contour line? Anything wrong? So there are a lot of debates among the coastal scientists of Bangladesh that where is the northern limit of the coast? Somebody is suggesting 1 meter, 2 meter, 3 meter, or even that. If we use the surface tide range, it goes even further north. But considering many things, after 1991 cyclone, we have considered that 3-meter should be the northern limit of our coast. If 3-meter contour line is taken into the northern limit of the coast, then how it can be divided into east-west direction. So another physical geographer, Professor Pramanik, he identified the coast into 3 major regime, or 3 major zone. This is the southwestern coast, just from this Vola big island to the western border of the country. This is southwestern coast. And this part is the south central coast, mostly covered the Meghna estuary. And this part is the southeastern coast. Some of the physical or geomorphological or geological characteristics of this coast are, if you go to the western coast, this is more or less stable, but broken. Broken meaning you cannot go from here to here by foot. There are lots of tidal creeks. But the land is a little bit stable, and innumerable tidal creeks, and one of the largest mangrove forest of the world is mangrove. It is located here, just sharing with India. So 6,000 square kilometer in Bangladesh and 4,000 square kilometer in West Bengal. And there are lots of dune systems, swamps, and other things. This is the central part. This is hundreds, nearly 300 offshore islands. Just many of them are very mature and newly accreted, and some of them are continuously being eroded. So erosion, accretion is a very, very common process into this part. And recent year, both erosion and accretion has accelerated. And there are lots of mud flat, and on the eastern part, what we said, that's nearly unbroken. It's a continuous coast shoreline, except a small delta here. The Matamahori Delta here, small delta. There is the second largest city, Chittagong. I know many of you know the name. Here is the Dhaka, the capital, and this is the third largest city, Khulna. So Chittagong and Khulna lies on the coast. And this is the world largest, what we claim may not be the largest beach. The Cox's Bazar beach is located in the southeastern coastal part. So, and if we go to the major land use type, why I'm mentioning that, this will later on come to the discussion. If you go to the major land use type in the southwestern coast, the major land use are Sundarban or land cover, Sundarban mangrove forest, Mongla port, just here, just on the north, Mongla port, the second largest port, and Paira port, a small and newly built port here, Paira port. And just on the northern edge of Sundarban, there are huge land use change and turn into shrimp farming. This is a major land use change, shrimp farming. And two major cities, Khulna, a divisional town, and here is the Borishal, another divisional town. Khulna and division, these are the major land use type in the western part. The central part, the major land use are what I should say, the offshore islands. You know, so many offshore islands are here, and the cross dam. We have made some cross dam in the across the in estuary, so that we can accelerate our accretion rate. And we have already connected some of the offshore islands with each other by making cross dam. And another major land use is the massive afforestation in these offshore islands, these mangrove species. In the eastern coast, the major land use type is the second largest city or port city, Chittagong. You know, in the subcontinent, this is one of the oldest port, or not in the subcontinent, the world. And this part, which is also an environmental threat, the Chittagong area is the ship breaking yards are located here, the major source of pollution. And Cox's Bazar is the most attractive tourist spot. It's a tourist spot of the country. And in this area, shrimp farming and salt farming. So these are the measures. So by this time, you get some sort of introduction with Bangladesh and its coastal environment. Now coming to our main part of the discussion, the principle of another part of this principle of sea level movement. So the two words, mean tide level and mean sea level, you know, the mean tide level and mean sea level, this actually sometimes makes confusion, or because they are synonymous to each other. So what is mean tide level and what is mean sea level? So if you see the a very usual definition in the dictionary, mean tide level is the average of mean height water and mean low water. And mean sea level is the arithmetic mean of continuous, that is hourly measurement of tidal water for a certain period. So in both cases, definition seems to be nearly the same. So whatever we say, it is a mean sea level, actually it is a tide level, or whatever we say it is tide level, it is actually mean sea level. But the only difference is that both are recorded in the tide gauge. Is the similarity. Both are recorded in the tide gauge, but nowadays from satellite altimeter. But in the open sea, mean sea level and mean tide level, they are the same value, same meaning. But whenever you come to the shore, and if the shore is broken, it's very, very funnel shape, then there is a deviation between mean sea level and mean tide level. Because if you take the data from the tide gauge, and then you study that to understand the mean sea level, so you are just inviting some sort of local noise, local natural process, as well as man-induced process. And what we see in most cases, our tide gauges are located just on the shore or in the interior of the creek or tidal rivers, and so many noises comes from the tidal data. And unfortunately, the last line of our slide I cannot see. How can I see that? Oh, I can. And the practically global mean sea level change does not reflect the same value of local tide level change. Then if we go to the next slide, then what we can say that this is another terminology the beginner should know the difference. One is the eustatic sea level change, and another is the relative sea level change. What does it means? What is the difference? Whenever we talk about eustatic sea level change, we immediately understand that it is a global sea level change. That is, if a certain volume of water mass is added to the ocean system, it is uniformly distributed worldwide, and it makes worldwide sea level rise or change, definitely rise, and that is called the eustatic sea level change. And this word was very popular until 1976. Why 1976? I'll be talking later. Nowadays, we are using the another word, relative sea level change, RSLSC, relative sea level change. It means despite the eustatic or global components, there are some local variations. So whenever we talk about sea level at certain location, then it is considering, it is including some eustatic process, but it has been mostly guided by the local process, and that we coined the word local sea level change. That is basically the local land-ocean interface. So the local land-ocean interface varies location to location, coast to coast, even region to region. Even in the eastern coast of India, or even different delta coast or our coast might have different with other coast. Just if you look into this two figure on the right, before that I said why we are coining the most of the sea level scientists are using the word relative sea level after 1976. There is a project, IGCP project 61. It was actually aimed to find out a eustatic sea level change of the world. So in the end of the project, the scientists come to the conclusion, it is not wise to look at global sea level scenario. Rather, we have to look the local or regional sea level scenario. And that is after 1976, the famous paper of Nicholas Morner that make some sort of, rapid change in the thinking area of sea level research. So if you see the right-hand side one, what you can see, that can you see that whenever what is oh I have to go no sorry, something is so here you can say that the land is no. you can see that sea level is rising. This sea level is rising because of global process or ice melting. But if at the same time, land level rises, either tectonically or sedimentation, siltation, there is nothing wrong because the local relative sea level is nearly zero. On the other hand, if the land level subside, maybe human intervention or natural process, and if there is no addition of water into the ocean or even thermal expansion, what will happen? The sea will invade into the land. So there is a real sea level change. So it has the second one, it is keeping back with the global addition of water, but the second one, it has nothing to link with addition of water. It is just local sea level rise because of the land subsidence. And it is happening in many parts of the world. There are some existing knowledges. Whenever we talk about sea level, what everybody knows. This is a very general concept. Everybody knows there is a positive link between sea level rise and temperature rise. And in that principle, as the globe is warming, so sea level is rising because ice is melting. But this literature, even only a few months back, 2 months back, another one publication came into the Nature. It shows that temperature rise and sea level rise is not always positively linked. And if you read carefully the literature of Nicholas Monar, he's even suggesting sea level temperature rise sometime reduce the sea level through evaporation. And he has mentioned that particularly in the northern Indian Ocean, the sea level may not rise because the evaporation, excessive evaporation due to global warming. Anybody may differ with his publication, but he has written a number of papers about the relationship between temperature and global sea level rise. The another concept is that due to ice melting, if a certain volume of water is added to the ocean will be uniform rise of sea level. That is not correct. In the previous lecture, it was very clearly mentioned there will not be uniformly rise of sea level because there are many countries which will be even uplifting. If Greenland is melted, Greenland will be isostatically uplifted and sea level will be falling there. So it varies on the location where it is located. And the third very common knowledge is greenhouse effect is usually considered to be the only major cause. That is, climate change is only major cause, ignoring the regional, local geological cause and anthropological cause. And the previous lecture has clearly mentioned how global process is related to the climate change, global process are related to sea level change. And the fourth is thermal expansion, that without adding any melt water, only thermal expansion may increase the global sea level rise. And it is found that IPCC report says that nearly 40 to 50% of the total contribution comes from the thermal expansion. But if we see these are the report scenario, IPCC report, many of the developing countries, particularly including Bangladesh, they have given adequate attention to the IPCC scenario. But this is a very generic, very common comments. Everybody has to have their own assessment. Every location has to have its own assessment. And the next one is, what are the major causes of sea level change? I should go very fast because we don't have much time. These are the major causes of sea level change. Global causes, the glaciation, deglaciation, we all know, we are all geologists. It's a natural causes. Greenhouse effect, the present cause is a human induced, and solar events, that is another natural cause. In the regional scale, particularly in our subcontinent, if we talk about, it is a glacial isotopic rebound, it is oceanographic process, and also atmospheric process. We are giving more attention to the local process. Whenever we talk about the local process, the very important local processes are the subsidence and upliftment, sedimentation, and human intervention. And on the right side of the panel, you can see this is a table. All the factors are mentioned here, the major factors of local sea level change, and the natural causes are shown in the green color. Climate change related causes are shown into right color, and human intervention into blue color. So you can see at local sea level change, both natural, human, and climate change are involved in every nation, every coast, every location. Considering this system, this is nearly the repetition of that what we exercise in the context of Bangladesh. Just many interlinked process, and all are interlinked to each other. Now let us see what is the general trends of sea level at the moment worldwide. If we look into the world data, there are about 2,300 tidal station. Somebody said 2,400 tidal station worldwide. Among them, 240 are administered by NOAA and 170 by PSMSL of more than 60 years record. And there are dozens of attempts made by the global scientists to assess the sea level changes worldwide. And they have found since 1940s till today that the sea level on an average is rising at the rate of 1.1 to 1.8 millimeter per year. This is just a range. So everybody's coming up on their own scenarios. But we look into the recent literature that is coming from the satellite altimeter. It shows that global average rise is 2.8 to 3.4 millimeter, nearly double of the previous assessment. It means it said that 50% of the contributions comes from the thermal expansion. But if we see the sea level change projection predicted by IPCC, they have always coming with a different picture. That is, they are suggesting that in 2100 years, that is 2100, the sea level will rise. In 1990s, they said 110 centimeter. That is the best, worst case, or the highest case. In 95, 98 4 centimeter, 2001, 88 centimeter. That is, they're gradually coming down. But in 2014, that is the fifth assessment, they are suggesting that the global sea level will rise nearly 108 centimeter. That is 1 meter by 2100. So this is the global scenario. But what is about the regional scenario? Regional scenario, I mean, particularly in our Bay of Bengal. So there are a number of publications on this area. And if we carefully look into this context, particularly in the eastern coast, earlier study shows that the sea level rise along the Indian east coast varies from 1 to 2 millimeter per year. Regional average 1.29. Then important reference is Unnika, Krishna, and Shankar, 2007. But when we consider recent tidal ultimate data, then it is suggesting that sea level changes is around 2 to 5 millimeter per year, except Diamond Harbor, which is very close to Bangladesh. So, the Indian coast sea level rises 2 to 5 millimeter per year, Diamond Harbor up to 5 to 4 millimeter per year. So it means sea level trends along Indian coast is within the range of the global range. It's not very far from the global range, except northern Bay of Bengal. But again, I am suggesting that Mornar, he is different. He has suggested that sea level remain stable in the Bay of Bengal or northern Indian Ocean. These are the list of his 2007, 10, 15, and 16 publications. Now, let us come to the situation in Bangladesh. What is happening in our part of the world? Bangladesh, this is the some of the topic. Say, the background. Whenever we talk about Bangladesh sea level, what is the general idea? The general idea is that Bangladesh is the worst victim of climate change induced sea level rise, and it is projected. There are many projected. The minimum 2 millimeter will be inundated by 2100, or highest 4.5 meter. That is 2 meter is the lowest figure, and 4.5 meter is the highest figure. On an average, there are many projections. And millions of people will be displaced from the coastal area, and they become the victim. And the coastal belt of Bangladesh would be the highly vulnerable location. Coastal belt of Bangladesh is already vulnerable because of many disasters, such as salinity intrusion, such as waterlogging, storm surge, and other, and projecting that sea level rise would be another potential threat for the coastal belt of Bangladesh. Under this background, our basic question is how much we know about it and how much we are responsible for it. Is the science well known to us, and are we responsible for that? We are in this paper, in this presentation, I will try to address some of this question through my 3 decades experience as well as from some overviews. Then, what are the sources of data of our the sources of data? Whenever we talk about tidal station, tidal data comes from, we have 47 tidal stations, mostly run by Bangladesh Inland Water Transport Authority, and 2 are operated by Chittagong and Mongla Port Authority. So these 2 tidal station has and the oldest tidal record is from Chittagong Port, that is from 1937. This is here located here. And among these 47 or 49 tidal stations, 5 or 6 tidal data are of 50 to 60 years old, are mostly used by the concerned scientists. This is Huron Point, just here. This is Mongla, just here. Chorchonga here. Khepupara here. And Chittagong is here. So 5, 6 data are widely being used by the scientists. And hydrometeorological data is collected by Meteorology Department, Water Development Board, and River Research Institute. Field data with the geoscientist or earth scientist, we go for the field evidence, geomorphological evidence, lithological evidence, as well as biostratigraphy evidence. I particularly interested pollen and diatom, and struggling with foraminifera and chronostratigraphy. These are the laboratory data. And recently we have satellite data. The map on the right top corner, this shows our investigation, where we considered our attention. So we have data collection from the field. You can see the ranging from east to west, nearly entire coast and offshore areas. As I mentioned in the morning session in a discussion, that we have a sample from the ocean, even from the swaths of no ground. But these are all graph sample. We don't have any vessel support to go for core sample, because we do not have that kind of. So we have some sort of graph sample, and we are studying that. But in the land, we have core from Khulna to Cox's Bazar, all along the coast. So these are the sources of data we have been using or been overviewed. Based on this source, we made one attempt. How reliable is the tidal data? So we considered 5 tidal stations, which are popularly been used by the scientists. And I'm not going the further details. That the conclusion is all these tidal stations are noisy. They are vertically noisy. They have been regularly destroyed or disturbed by tidal surge, spot surge, human intervention, mechanical error, technical error. So the data is noisy, and it is not wise to make any kind of secular conclusion based on this noisy data. Regarding the geological data, we have a record up to 10,000 BP. And there are 3 or 4 major published documents, one including ours as well as other Umitshu and Banerjee from West Bengal. That is also included as our part, but he's from West Bengal, and as well as Rashid. And these are the graph. And if we see that nearly all suggested there is a continuous rises of sea level during the Holocene, but we are suggesting it's not continuously rise, it is a fluctuation. There are at least 5 phases of transgression and regression on an average 1,000-year cyclicity. But only one paper is suggesting, that is is Rashid, that there was sea level higher up to 5 meters in the mid-Holocene. We do not find any evidence of high strand at mid-Holocene time in Bengal, but Rashid is arguing in favor of 5 meter higher sea level during the mid-Holocene time, and her record comes from the Pleistocene terraces in the Madhupur area. And if we go for the contemporary present, and this is our data, we used mangrove pollen from different core, particularly from the Khulna region, and this is the shoreline we reconstructed. That the shoreline was nearly 60-70 kilometer interior, about 7,000-8,000 years BP, and that very much matches with the West Bengal data. And these are the marine transgression, and we can see the highest rate was 3.6 millimeter during the mid-Holocene time period. So this is our, but on an average, sea level is has been rising at the rate of 1.7 millimeter per year during the Holocene. About the recent sea level change, what are the scenarios? The scenarios, three major official documents: SARC Meteorological Research Center, CGIS. CGIS is basically a government consultancy firm, that is the government advisory institute. They give the suggestion to the government, and Department of Environment. So SARC Meteorological Center, they have suggested, based on the data from Huron Point, Chorchonga, and Cox's Bazar, which I mentioned earlier, that in the western side, the sea level is rising at the rate of 4 millimeter per year. In the central part, 6 millimeter, and the eastern part, 7.8 millimeter. So west is low and the east is high. CGIS, just after a few years back, they suggested that Huron Point 5.5 instead of 4, 4.5. In the central part, 7 instead of 6. But in the Cox's Bazar area, 5.5 instead of 7.8. So there is a difference between the two. Department of Environment, which is already published in 2016, they are giving us some sort of dramatic scenario, which is very difficult to accept. They are suggesting this report, official report of the government, that in the southwestern part, that is where it was 4 millimeter, it is nearly 8 millimeter. In the central part, where it was 6 millimeter, it is up to 10 millimeter. And the eastern part, where it was 7 millimeter, it's nearly 21 millimeter. And it shows that western coast, southwestern coast, nearly double in the southeastern coast, only 150 kilometer or 200 kilometer apart away from each other. So when this report was published, it was seriously been under challenge by the concerned scientists. And that how it can be, it doesn't follow either the principle of climate change, nor the principle of geology, until and unless there is a barrier in between. But there's another ongoing work is going on. It is not yet published, based on satellite altimetry. It is suggesting that the sea level ranges between 2 millimeter to 12 millimeter in the coastal area of Bangladesh. But as I said, it is personal communication. On an average, 6 millimeter. And as I am somehow part of it, I can say that this 6 millimeter can be accepted, but as I said, it cannot be referred, which is not yet been published. It is on the process. But if we go to the this is the scenario of the government of GOB, Department of Environment, 7 or 8 millimeter in the west and 21 millimeter in the east, and only difference is around 200 kilometers. So how it can be realistically accepted, I have no idea. But if we think the geological process of this area, on an average, this area is an uplifting zone, you know, a tectonically uplifting zone, and this area is subsiding zone. And then going to the next is by some individuals. Why every time is coming? It's not going. Individuals means some individual research, particularly under their own projects. Sea level along Bangladesh is suggesting 25 millimeter per year, the worst case by Wahid. Fathic suggesting 10 millimeter to 17 millimeter in the northwestern, southwestern part, 10 millimeter in the just on the shore open system, and 17 millimeter just further inland in a closed system, Khulna city, 120 kilometer into the shore, into the landward side of the shore near Khulna. Rogers suggesting a little bit conservative, 5 millimeter at Huron Point, where it was 10 millimeter at Huron Point, it is nearly half, 5 millimeter at Huron Point, and 15 millimeter or 5 millimeter in other places. But they are using the same data, as I said, same tidal data. The only recently, what I said, the satellite altimetry data using, Baker suggested that sea level ranges in the southwestern part 2.1 to 2.7 millimeter per year. On an average, this is the central part 3.2 to 3.6 millimeter, and in the eastern part 1.3 to 3.4 millimeter. So if we summarize this Pethick and Orford, this is widely been cited. This publication is widely been cited to understand the sea level scenario of Bangladesh by the policymakers and the academics. But if we summarize all these things, this is the graph. You can see I have just plotted all this record into the sea. The highest is 25 millimeter and the lowest is 4 millimeter. Just what I have mentioned in the previous one. These are the western part of the coast, these are the central part, and these are the eastern part. If I make an average of all these things, southwestern coast is ranges from 2.2 to 25. I should say the most likely 7.8, and the most likely the central part 5 to 6 millimeter, and the eastern part 4 to 5 millimeter. And if I compare all these things to global scenarios or the regional scenario, southwestern part global or regional is 2 millimeter. If we accept that, 6 millimeter more than the global average. South central part 4 millimeter more than the global average. Eastern part 3 millimeter more than the global average. It means in case of Bangladesh, the coast has 3 to 6 millimeter additional sea level rise due to local driven anthropogenic cause. We are suggesting these 3 to 6 millimeter additional sea level rise, it is possibly the anthropogenic cause, and very insignificant important link with the global process. So global process and regional process, what I should say, these are climate induced process. We do not have any idea about Himalayan cryospheric impact on the Bay of Bengal, and hydrometeorological impact and oceanographic impact. We have some sort of ideas, but not in detail. If we go for the regional cause of anthropogenic, that is human induced causes, what are the major causes? The major causes are the diversion and what we saw, the reduction of the water and sediment flow in the catchment, massive land use change, and at local scale is the effect of coastal embankment and polder, accelerated subsidence, and decrease of sedimentation, which is also linked with the supply of sediment and supply of water from the upstream, and the groundwater extraction. These are the major anthropogenic factors which are affecting the system. So if I make, may I know how many minutes left? Just anyone?
Sorry, you can continue, sir. No problem.
So if I go to the discussion, so for example, the thing is that initially in if we go see the literature of 1965-60s, the annual sediment supply into through the Ganges Brahmaputra system was 3 billion tons. Now recently it has come down to 1 to 1.6 billion tons, nearly 1/3 of the total influx. And this is a very widely cited graph by Professor Colloquium from Lock Haven University, USA. He's Bangladeshi in origin, and he is suggesting that you see the dramatical change of sediment influx into the catchment through GBM system from the upstream, and sediment carried by the GBM system is roughly deposited. Another publication by Goodbread and his team, they're suggesting this 1 billion ton is equally distributed among the tidal flood, that is floodplain, shelf zone, and deep sea. But recent studies shows that few portion, that is 10% of the drifted sediment are being redeposited to the Sundarban areas, because in the Sundarban areas from the seaside, because the Sundarban area nearly sediment supply is seized because of the decrease of the upstream flow. But our study shows the sedimentation rate. We have done a number of studies. Our study shows that sedimentation rate in the southwestern coastal belt is about 3.1 millimeter per year, which during the geological time has a very balance between the subsidence and sea level change. But in the recent time, because of anthropogenic causes, it is not keeping back or keeping balance with the subsidence and other sediment starvation. And under this situation, if this reduction of sediment supply from the upstream is continued or ceased, then the growth of the entire delta, both vertically and horizontally, would be seriously curtailed. And that will invite our inundation by tidal water. I should rather say it is an amplified tidal water due to human intervention. If we go our local scale, beside this regional cause, if we go to the local scale, in 1960s, a government has, since 1960, over the last 40, 60 years, government had, make lots of polders to encourage to the agricultural production into the tidal flood area. So this kind of artificial blockage by polder not only stop tidal water inundation, but also sees the sediment supply to the floodplain. In one hand, we are not getting adequate amount of sediment supply from the upstream during the last 4 decades or 5 decades. On the other hand, we are making lots of polder. As a consequence, the sediment so far being received, all are deposited on the riverbed. None or very few is coming to the floodplain. And as consequence, the sediment supply, sediment intervention, starvation, the lands are being subsided. And you can see the lands are subsiding and the riverbed are going up. And it has been found that over the 4 decades, the land and on an average has already 1.5 meter going down. The elevation has reduced to 1.5 meter in the closed system. But in the open system, somehow it is making some sort of balance by the sediment coming from the seaward side. These are some of the pictures. The top pictures I have taken on my own. You can see the river bed is going up by siltation, and these are permanent water logging because the system is not working. And this I took from my friend, Dr. Dotto. And as a consequence, what happened? The concept of tidal river management came. This is the embankment. The local people, they broke the embankment and allowed the tidal water to come into the floodplain from the rivers. So this is called the tidal river management. This is a locally devised, that is the traditional approach to compromise with the subsidence. As the pilot project done by the local peoples are showing some sort of good result, then government from 2001 by Bangladesh Water Development Board, they had accepted this as a formal approach, and Bangladesh government is now considering by ERD as a tidal river management as some sort of adjustment process with the subsiding to compromise or to make a compensation to the local subsidence. So actually mostly suitable for low-lying floodplain areas, but not suitable for the uplying area or inland areas. It is mostly suitable for the very southern part of the delta. Something is wrong every time. Oh, my cursor. Rapid subsidence. As the area is not getting adequate amount of sediment from the upstream, so what is happening then? Lands are being rapidly subsiding. We have up to now, we have near about 20, we have near about subsidence data from 120 locations. So we compiled all the locations and mostly coming from the 100 southwestern region. And we compiled all those data together. And this is the map. I should say that is the map. It shows that the southwestern part, this is outside the Sundarban area. The subsidence rate is very high, and most subsidence rate is the south central zone. And the subsidence varies from the figure. If you go, varies from something. Cursor is functioning not. The subsidence varies from 2.5 millimeter per year in the southwestern region to 4.8 millimeter in the central region and 2.5 millimeter in the eastern region. So data shows that the south central part of the coast is subsiding faster then the rate of the southwestern and southeastern. Why south central part is subsiding later, that is to be investigated. But the main causes of subsidence in the southwestern part and other part is the reduction of discharge and sediment influx from the upstream. Salinity intrusion, as one of the major causes of our salinity intrusion is the tidal amplification of tidal range. As the area is subsiding, so if you see over the last 30 or 40 years, when the total saline affected area was 83 million in 1973, it is nearly more than double. Area is now been under saline water intrusion, and these are the two figures. One is the groundwater salinity and another one is the surface water salinity. I'm sorry, my cursor is not going. Sometimes it is going forward, and this is the subsidence. Amplified tidal range. This is another more important picture diagram. So what we are finally suggesting that because of the reduction of supply of sediment from the upstream, the impact of tide has been accelerated, and we call the amplified tidal range. And amplified tidal range not only the consequence of lower reduction of the sediment supply from the upstream, but also the blockage of sediment supply in downstream as well. For example, this is an example of a small dam. Here at Feni, there is a small dam on the Feni River, we call the Mohori Dam. And when the dam was constructed in 1980s, it means immediately after the dam, the huge amount of land was accreted below the dam, and the tidal range was amplified on an average 50 centimeter. So this is an artificial amplification of tidal range. Same thing is happening from other part of the country. So it's just a small scale demonstration how the small tidal, small scale intervention of the river flow can increase the tidal range. Impact of storm surge, I'm not going further. This is a very common picture that the entire area is seriously been affected by the tidal storm, and this has been amplified because of the because of the increase of the tidal range. If the tidal range was reduced lower as in the past, the impact of storm surge would have been much lower. Amplified tidal. Conclusion. So I'm just coming to the conclusion. What I am concluding that if we through the sea level change of Bangladesh during the Holocene time period, it was mostly been driven by controlled by the naturally induced process, and very little to do with the human intervention because there was no human beings, and the average rise was 1.07 millimeter per year. But we look into the present sea level rise along Bangladesh coast, it is mostly been led by or controlled by the local and regional anthropogenic causes. And Bangladesh therefore needs immediate investigation to find out the real scenario of future sea level change, considering its local scenario, ignoring the general IPCC scenario. So process operating locally, particularly sedimentation, compaction, and subsidence needs to be assessed carefully very soon. And what we said, what we see in the coastal area of Bangladesh, it is not actually the secular sea level rise, it is actually amplified tide level rise. With these few words, I am concluding because of time constraint. And thank you very much. If there are any question to ask, thank you.
Thank you, Shahidul Sam Islam sir. It was indeed a very detailed as well as informative session, and you have given a very nice PPT regarding the introduction to the Bangladesh geology. Most of us are not familiar with the Bangladesh geology, so I think it helps. So if there are any questions from the audience side. Actually, there is a question from Mr. Keshavadas. Is the sea level rise data corrected for the subsidence?
Is sea level data is corrected?
Yes.
Still lots of, we are doing lots of work, the how sea level and subsidence are linked, because the subsidence data we are coming, we are also struggling with the subsidence data. Somebody is collecting the subsidence data from radiocarbon data, somebody is doing on the lithological signature, somebody is there is no common methodology, so the scenario is varying, so we cannot accept any standard subsidence till today, because I am arguing that we use the radiocarbon data, we said this is the best way, but there are archaeologists, they are using the archaeological data, but how do I know whether it is in situ or drifted, so still struggling with the exact or accepted subsidence rate until we cannot make a standard subsidence. That is, I am arguing that we need repetition of work to quantify the subsidence rate. So it is still a unanswered question to us. Yeah.
Okay, sir. Hope the answer was clear.
Somebody come with model study from remote sense data, which we will not accepting, which is this exaggerated data, is suggesting even centimeter per year. It's not accepted.
Okay,
there was
doctor.
one more question. There was one more question, please. There are two questions.
Okay, sir.
Can I?
Sure, sir. You can ask directly.
Hello. Could you check with the IPCC AR6 sea level projections for Bangladesh?
I have not seen the 6. I have seen the 5.
Because, so what you said, and there is a lot of difference. There are 2 points, I think I remember. Heron Point and Cox Bazar, some data is given 0.76 or something like that for Heron Point by 2100, 0.76 meter. And the Cox Bazar, it was projected as 0.57. So please check that, because but anyway, that subsidence on the Cox Bazar is on the eastern side, it is less. Heron Point, it is more.
Yeah.
So maybe the subsidence or something like subsidence has to be corrected for sea level data in any case, if it is a tide gauge data.
Yeah,
Unless you correct it, it cannot be used.
Yeah. That we said that we examined, we checked 5 tidal stations, and we said that these are noisy data.
Right. So thank you. You please check this data also. Please check this.
Sir,
may I ask you one question? Hello.
Sure, sir. Please go ahead.
So I am Srinivasan, retired director from Geological Survey of India. Hello.
Yes, please. Hello.
Please.
Sir, what is there any role of neotectonism in the subsidence or the river distribution migration in this delta, this Bengal delta?
Yeah,
what is the role of that?
Yes, some people are arguing, there are some records that the interplate, Indian subcontinent plate, it is moving northwestern direction at the rate of maybe 1 or 12 centimeter per year, and as a result, the east-west distance is reducing, what is forcing to make some sort of tectonic readjustment. And there are some papers coming out that yes, the subsidence and neotectonics are have some sort of link. Yeah,
because the neotectonism along the coast, all through the east coast, there are significant evidence slowly, but that is a bit slower than the sediment supply and all the very good reason you have ascribed.
Yes.
So maybe combination of factor.
As I said, that even some bodies are arguing that that because of the sediment load, the sediment load,
yes.
the seasonal variation of the sediment load, we are getting plenty of sediment during the monsoon, but the sediment is seized during the winter. So because of the load differences, so it has a response to the intergeological process of the region. Yeah.
Okay. Thank you, sir. Thank you.
I think Dr. Linda Alpert is having some kind of question, sir.
Yeah, so it was a nice presentation and very nice to see a lot of landforms in the coastal part of the Bangladesh. Actually, I was quite curious to know, like you had constructed number of barriers across the tidal flat area, and you had mentioned that the siltation along the river has caused or these barriers have stopped the water entering in the floodplains of the tidal flats. So, but it was curious to see that there was no siltation or sedimentation rather, or barrier formation along the mouth of the rivers. Which means that do we not having sufficient amount of sediments reaching to the mouth of the rivers rather than even though it is not.
Yes, I understand. I actually, because of time constraint, as I said, we have a number of work even in the offshore areas, and we have checked the bathymetry of the shelf. You know, if we check the bathymetry of the shelf, the level is going up, because all the sediments coming through the magna story, as I said, in the southwestern part, sediment supply is nearly ceased because of the Gorai Madhumati river. It's totally silted up. What the sediment is coming through the magna story. So when the sediment is drifted from magna story towards southwest, is being deposited on the shelf zone, you know. So in front of the river mouth, there are the piles of sediments. Even some places in the Sundarban area, river is deeper than the shelf, you know, because of which is again making another artificial blockage. So now we are suggesting that we are quite busy with our water resource management, and we should even focus to our sedimentary resource management, because the sediment, how the sediment is being redistributed within the floodplain. If we make a artificial blockage of sediment influx and sediment dispersion and sediment distribution, it will create local geological hazard, environmental problem, as well as tidal amplification. So it is, and I'm just in the favor of and arguing. It might happen that I will be in coming up with some write-up. Actually, the man-made geomorphology of the coast of Bangladesh. So actually, Bangladesh geomorphology is being modified by the human beings. So it is our man-made geomorphology. So, but the quantification of this argument, it requires more and more field evidence, more and more data, and that is the way we are working. You know.
Yeah, I have one more point to raise. It's like you have your eastern side was mostly tertiary formation that you have mentioned, where the input of rivers are much lesser, as I understand from the geomorphological map that you have shown, considered to the western part. But the rate of sedimentation or the rate of sea level is much higher in the eastern part compared to the west and central part. And also you have constructed some dams across the islands in the central part. Does it have any influence in the sedimentation pattern in that area, in the central part or sea level?
I say in the central part, these are not the massive, the dam. These are actually cross dam connecting the two islands, so that we can encourage the land accretion. And that has given us few lands in the magna estuary, but it means the sediment flow is diverted to another direction. You know, the most of the discharge nowadays is coming from not from the Ganges system, it is coming from the magna system and the Brahmaputra system. You know, but still, as I said, that in the central part, the erosion is higher. At the same time, sediment supply is also higher. But in the southwestern, that is Sundarban area, that is starving with the sedimentation. Still in the eastern and in the central part, some sort of sediments are coming from the Ganges system, Brahmaputra system.
Okay, thank you, sir. And the last one observation, what I was seeing that
another very uncertainties remain. You know, that we are dealing with the sediments of nearly 16 kilometer deep. You know, it's a big 16 kilometer sediment piles. So few meter is not a matter over there. So it's really challenging work. We're not dealing with a stable shoreline or a stable geology. It's a very dynamic system.
Yeah, and this sea level, when you consider the gauge data and the sediment, they have this response time difference. Like natural archives respond in a different rate compared to the instrumental records. So while considering the sea level of the Holocene period with the latest sea level trend from the gauge data, the response time would be different for both proxies. Or rather, one is instrumental data, another is sedimentary formation, and sedimentary formations respond in a different rate compared to the instrumentation data. So we may have some disparity in that point also. I just wanted to mention that. Thank you very much. It was a very nice presentation.
Yes, it's a very good comment. What is the major challenge for us? The challenge is that we cannot trust the tidal data because tidal data is noisy. So we have to go to the alternative data, that is the geological data. So whenever we go to the field, we can get lots of evidence. The best way is to, if we can correlate the sediment sequences from one place to another, and we need series of long, series of work. and that is the we are doing. For example, if we go to the Sundarban areas, we can see easily some paleo dune system. So, but in the other places, it's subsiding. But even in this within the Sundarban area, Sundarban is still an open system. Open system means that there is no built up. But in the north of Sundarban, lots of artificial blockage, lot of artificial intervention. So a geological signature could be one of the solution, but geological signature must be supported by the chronological signature. You know, the chronology is an important thing which is very, very expensive. So that we said that with limited resource, as a geologist, I'm not a geologist, I said to the pro geologist, we are struggling and we are looking for the field evidence. Once the adequate number of field evidence comes from all sort of geomorphological unit, from the dune system, from river system, from fluvial system, then we can correlate all these things in the context of geochronology, in the context of phases and so and so and so. Then we can get some sort of acceptable data. But this is really a gigantic delta system, you know, so it is endless. So we are struggling. Thank you.
Thank you, Shahidul sir. I think we are already late. If some participants are having any particular question, you are free to contact Shahidul sir directly. Maybe with his permission, I will share his email here.
Yes, please share me, and through you, my heartiest congratulations and heartiest gratitude, and thanks to all the participants at this moment, 128. So I said, this is what I said, some sort of emotion works when we all the South Asian peoples talk together.
Yes,
you know, so talk together. And I said this is a united world, united community, united scientists. So we have to extend some sort of support to each other based on our experience. In the morning session, I asked a question to Professor Nigam, you know, he is very close to me, how we can cooperate to each other. So I seek support and cooperation from your side, and also extend our support to you. And particularly, I should say that Suresh Gandhi is widely known to me for last 3 decades. So is Suresh
yes,
in the line?
Yeah,
Suresh, thank you. Thank you very much for considering me as part of your panel.
Yes,
so thank you all of you for your kind and passionate hearing.
Thank you, sir. Thank you for the kind words.
Thank you.
Yes, sir. Thank you very much.
Thank you, sir.
Thank you.
Okay, next I would like to invite Miss Asha Merin-Jolly, Assistant Professor from Department of Geology, Christ College, for introducing our next speaker. Ma'am, over to you.
Thank you, sir. So our next speaker is Professor N. Parthasarathy. He is a fellow National Academy of Science and is currently working as professor at Department of Ecology and Environmental Science, Pondicherry University. He has completed his master's and PhD from University of Madras, and he has more than 30 years of teaching and research experience and has guided 16 PhDs and is guiding 3 of them now. Professor N. Parthasarathy has published 110 research papers in international and national journals, including 2 each in Nature, PNAS, Global Ecology and Biogeography, and a lot more. He has also published 4 books and presented 160 papers in international and national seminars and conferences. He is a life member in 6 professional societies, also invitee of American Government for Global Liana Research Collaborative Program at University of California, and invitee of European Government for Global Dry Forest Research in Switzerland. He'll be giving a talk on climate change and human impact on ecosystems and conservation needs. With immense pleasure, I invite you, sir, for the talk. Over to you, sir.
Thank you very much. Am I audible?
You're audible.
Yes, sir. Dear Professor Suresh, Mr. Tarun, and other organizers of this Colloquium, dear participants, scholars, and students. Well, it is indeed a pleasure to be part of this Colloquium program organized by University of Madras and Christ College, Irinyalakuda. I chose to speak on the climate change with the special reference to the importance of establishing permanent research plots, what are called as ecological monitoring stations, to better understand ecosystems and to have an idea about how systems are changing over time with respect to the experiencing climate and other scenario in those locations. So with this briefing, and can I request Mr. Tarun to share the screen, please, the PPT?
Yes, sir. Yes, sir. Sir, I think your video is off.
Okay. Oh. Fine. Okay.
Yes, sir. Now it's
Okay. It's a pleasure for me to be a part of this colloquium, and we shall be talking about during this course of about 45 minutes or so, how much climate change and coupled with the anthropogenic activities on various ecosystems, it impacted and the conservation needs of the systems to have the planet Earth in a stage supportive to all biota. Next, please. Well, we are at a crucial junction. We have been talking about the climate change and global warming, and most climate models predict that a substantial warming of the atmosphere by 2 to 4 degrees Celsius will accompany increase in the concentration of various greenhouse gases. CO2 level has risen from 280 ppm during the pre-industrial era to 400 plus ppm in the recent times. Now, to absorb this excess CO2 in particular, released through mainly fossil fuel combustion, deforestation, particularly in the tropical region, wherein it is always on the progressive side, and the land use change that are happening. So we need to have great greenery by way of our economic way of biological means of carbon sequestration. And there has been a necessity to better understand ecosystems to manage them in a manner that could be in a sustainable way. We could make use of the resources and have the benefits of the support systems or the ecosystem services which are rendered by them in a changing scenario. And we have talked about deforestation, particularly in the tropical zones, pollution through various sources, and overexploitation of a number of resources leading to population reduction and biodiversity loss at the end. So next slide, please. We have been trying to understand the systems by way of once study static data as well as from many of the permanent research stations. So there have been a couple of recent books on the scenario of biomes. Can we have the world biomes book you projected earlier? So we have the very latest book, Encyclopedia of the World's Biomes, 2020 publication, edited by Goldstein and De La Sala. So this is in 5 volumes and gives us an idea of it's about 3,770 pages. Such a detailed preparation. We are really fortunate to have such a latest book that gives us an idea about across the globe various biomes and the extent to which systems are changing with respect to Anthropocene. So next, please. This can be obtained through various sources. It's Elsevier publication. This is in 5 volumes, and it has covered all biomes and particular reference to forest and the marine systems too. And anthropes have been given a special focus because of the changes that are being happening due to various human activities. Next slide, please. Well, As we will see in this book, as of now, world's terrestrial ecosystems total to 431 major ecosystems at the globally aggregated level and 1,778 ecosystems when segregated by the biogeographic regimes, namely Nearctic, Neotropical, Palearctic, Afrotropical, the Indo-Malayan, Australian and Australasian, and the Oceanian region. So this is a very good coverage, and if people could access this from Elsevier publications, it's a very detailed coverage on the global ecosystems, and in anthromes are given special focus. Next slide, please. Coupled with this one, so the other two books, can we have, Dr. Tarun, the other two books that have been shown? One is Biogeochemistry. This is again 2020 publication by Schlesinger and Bernhardt. An excellent coverage of the subject and analysis of global change, and various elemental cycles are dealt with from historical to anthrome situations. And the other book, again, 2019 publication, Biodiversity and Climate Change, by none else than the famous conservation biologists Thomas Lovejoy and Lee Hanna. So these three together covers many of the recent analysis of ecosystems, and in a particularly in a changing global environmental scenario. Next slide, please. So when we move, next please, I have talked about the book in 5 volumes, global number of major, and when segregated by biogeographic regimes, 1,778 ecosystems. Next slide, please. I'm not detailing the color codes and all. So as of now, 1/3 of the world's landscape is used for various purposes by way of land use change for buildings, agriculture, grazing for domestic animals, etc. Massive degradation and destruction result in biodiversity loss, coupled with natural as well as man-made calamities. But at the same time, people depend on resources for living, and to many rural people, it forms the very livelihood for them. Resources, in fact, are obtained from various biomes, starting from the northernmost poles to the Antarctic region. So different biomes providing us various resources, particularly from the tropical world and the temperate boreal systems. Next slide, please. We shall be looking at this in later context. As we all know by Whitaker's picture, that global distribution of biomes is primarily governed by climate with respect to mean annual precipitation and mean annual temperature. This picture with respect to 2020 projection, after a few slides we will be looking into, in which I will be particularly drawing your attention with respect to how by 2020 project changes are being shown there. Here you will see the major zones: tropical, warm temperate, cold temperate, and the Arctic alpine region in the temperature ranges of 18 to 30 degrees Celsius and 18 to 3 degrees Celsius, and then 3 to -7 and -7 to -15 Arctic alpine zone. So there it will be a precipitation on the this axis and temperature on the x-axis you will see, but anyway it will be with the color code very clear there also. So this is very important to understand, and in the other picture you will see how the changes are clearly shown. Next slide, please. Well, the poles are particularly much affected due to climate change, and we all know that the North Pole or the tundras, the Arctic tundras, is a treeless vegetation. So it's completely occupied by low shrubs and herbs, and these are all permafrost condition, and many adapted to are ephemerals, adapted to short span of life for each life form, and then within that they try to complete their life cycle because of the climatic constraints that they are exposed to. Next slide, please. Down south of the tundras, we have the boreal forests, which form about 29% of the global forest is from the boreal temperate coniferous forests. And these are important global carbon stocks. So bulk of it, their diversity, as you will see in the next slide, the diversity in such boreal forests less, but their contribution to global carbon stock is much higher. Next slide, please. So the conifers are important global carbon stocks, but constrained by climate with just 100 working days, 100 photosynthetic days in a year because of the climatic constraints that they face. Next slide, please. So here is a coniferous stand of the temperate Kashmir Himalayan forest on the bank of Sindh River in the Kashmir Himalayan region. And these conifers are particularly adapted, and the tree canopies are cone-shaped to conveniently glide down the melting snow as when the temperature warms up. The next slide, you will see that the stands are so closely packed, look like plantation areas, and their diversity, just 1 to 3 species per hectare in this stretch of Kashmir Himalayan forest when it comes to tree diversity. But look at the stand density or the forest tree density, so much packed. These are natural stands but look like plantations of trees, and these contribute considerably to the carbon stock of the Kashmir Himalayan region. So despite the low diversity, their contribution to carbon stock is substantial. Next slide, you'll see that these forests are also targeted for, like any other or many other ecosystems. So dependence on various resources, as you see the logs here. So deforestation has been progressing in many of these areas too. This is one of the study sites of present research program by one scholar. So and these are some of the hitherto unworked sites. So those areas are not also spared for extraction of various resources, that being the nature of or the extent to which these systems are subjected to. So despite the conditions of climatic constraints, but resource dependence is there in all biomes. Next slide, please. Well, when we talk about the species-rich tropics, rainforest canopies are the biological frontiers. So high biodiversity and very low density of contributing tree species, many of which are important sources of timber, food, fiber, and a number of natural chemicals that are helpful in fighting various human diseases. And many of them, these forests are also the sites wherein we have native genes of cultivated original germplasm sources of cultivated crops. So such forests are important for various newer innovations that we would think about and solve various world's problems in years to come. Many of them we have been utilizing for various purposes, and bulk of them still to be explored for their potential. But much before that, we have been losing without knowing what we are having substantial tracts of natural tropical forests. Say, for example, Amazonian region. Next slide. I shall be drawing your attention at a later context when we talk about the permanent plot in Brazil. So inventories are made to understand how much of diversity we have, and rather than once sample studies, long-term permanent plots help a lot in better understanding the systems and also to better understand system dynamics, how changes are happening with respect to various environmental factors, particularly climate change in the current context, coupled with anthropogenic impacts. So I'm not going to the details of the methodology here beyond the purview, but the emphasis I'm trying to give here is such larger the area and longer the time frame when these sites are monitored, marked with the permanent provisions, each tree being permanently tagged, and once generated data and periodical monitoring helps us a lot to understand how systems are responding with respect to various conditions to which they are exposed to, both natural and anthropogenic. Such large-scale data go to ultimately contributed by individual research teams from various parts of the globe, and thus we would have what are now called the GLD, Global Liana Database for the woody climbers of the world. Okay, so we now have Global Liana Database ready, global tree contributed by a number of researchers who have been over several decades working on the woody climbers. And I shall be drawing your attention at a later context about the importance or the significance of increasing abundance of lianas in the tropical world with respect to changing climate. And before that, I shall give you an idea about the global tree database. The global tree database will be out soon. We are in the final stage of compiling at the global level tree diversity data, and in very recent times, whatever have been compiled at the total global level, it has been done for the tropics, but for the whole globe now, global tree database will be out soon to the public domain for many to make use of. And such efforts over a longer period of time, data generated from various global sites, and how much these are valuable in understanding the system with respect to the prevailing or changing climatic conditions. Next slide, please. These are all maintained by different institutions. As of today, colleagues, we have a total of 73 global forest plots spanning 28 countries, in which 7 million trees are permanently tagged with aluminum tags, covering a total of 12,000 tree species. Now, there are a number of programs which are supporting these. The Center for Tropical Forest Science, a wing of a Smithsonian Tropical Research Institute, Washington, D.C., and it's a center in Balboa, Panama. So, has been the coordinator for many of the CTFS plots, and the program Forest Geo, Forest Global Earth Observatory, is a global network of scientists and researchers dedicated to advancing long-term research in world's forests. So realizing the importance of a collaboration with many local institutions to strengthen science in an era of rapidly changing landscapes and climate, to better understand forest dynamics and predict changes with respect to changing scenario. Okay, so world over, we have many sites. Only Australia is missing in this one. So they have their own programs. But in fact, the next meeting was supposed to be held in Australia, but it is delayed because of the COVID situation. But as of now, we have in 28 countries the programs going on. So many of those who are interested in long-term research programs on aspects ranging from microbes to mammals through large trees, there are a number of opportunities for various branches of science, not only biology, ecology, and geology, but spanning a variety of subjects and academia. So people can log on to the site CTFS or Forest Geo. How many sites are available? So here it is indicated in this global map. So you can go to the site, get to know the details about it, and there are opportunities, fellowships listed there. You will find very useful. Next slide, please. I'm not going to the details of it much. Now, here is a picture, current and projected future by 2050, mean annual temperature and precipitation of the CTFS forest geo sites of the world, superimposed upon the previous Whitaker's classic climate biome distribution map we have seen. Dots represent here average climate from 1950 to 2000, and the wedges represent the range of projected climate change. Now, this gives people a better idea of how, with respect to the in various biomes of the world, here codes are tropical rainforest, tropical seasonal forest, seasonal dry tropical forest, temperate rainforest, temperate seasonal forest, woodland bar savanna, woodland bar shrublands, then temperate grasslands, boreal forests, and for tundra ecosystems. So that way one will be able to better understand where the changes are prominent, where the changes are mild. So with here up projection from 1950 to 2000 given. So these are compilations from the efforts taken by large scale coordinated effort of forest geo sites. Next slide, please. So this is one of the first few large-scale, long-term ecological research plots established in Barro Colorado Island, BCI, Panama, in Central American region. So look at the dense canopies of it, and this secondary forest, they have chosen a large scale world's first 50 hectare plot to monitor, to address various ecological questions. How many trees and how many species of trees are there in a few hectares of forest? How are these given species distributed? How might the distribution of these species affect various forest resource using animal communities, the leaf eaters, the folivores, the pollinators, the nectarivores and pollinators, and the forest frugivores, which in turn involve in dispersing the propagules or seeds of these, and how changes are happening with respect to forest growth, recruitment, mortality, regeneration patterns, and many other aspects of study ever since initiated way back in 1975, world's first LTE or 50 hectare plot, BCI Panama, with the efforts of Howard University, Dr. Hubble, Foster, and Condit, many other teams of people who have been pioneering in this. This is one of the first few CTFS plots, Center for Tropical Forest Science, Balboa, Panama. Next slide, please. I'm just selecting a few from each continent to give you an idea, but if you log on to CTFS or Forest Geo CTFS plots, you will get to know the details, and wherever you are interested to work in terms of knowing about the fellowships available, programs available, subject coverage they have currently, you will get to know. So Africa, for example, Ituri. So you have a 40-hectare plot with the dimension given here, 445 species and 2.88 lakh tree species in the 40-hectare plot. So Korup, Cameroon, we have a 50-hectare plot. 50 hectare is very common in CTFS protocol. They maintain everything, database is maintained periodically. The team meets to discuss about, and biological monitoring programs, Biomon, if you log into, you will get to know the details of the protocols. Okay. Nigeria, so you have a 20.2-hectare plot. Next slide, please. You have a number of sites in Asia, ranging from just a 2-hectare plot in our regular morning walk site in Bukit Timah, Singapore. Okay, so, and Thailand has a 15-hectare plot and 25 hectare in Taiwan, and they have another 50-hectare plot in Thailand itself. 52 Lambir National Park was the second one after BCI established. Look at the tree diversity, one of the highest, 1,182 species in 3.59 lakh stems of 1 centimeter above diameter in the 52-hectare area. And continuously, we have in India Mudumalai deciduous forest, 50 hectare from CESIISC Bengaluru maintained. So it's a deciduous forest with 72 species and 25,000 stems. So these sites are being monitored, and supports are provided by CTFS in terms of the technical skills, as well as the field work and data analysis and publications as well. And Singharaja Biosphere Reserve in Sri Lanka, we have a 25-hectare permanent research plot, 204 species in 1.93 lakh stems. Next slide. Here is a lowland picture of the lowland dipterocarp hill forest of 25 hectare size in Singharaja Biosphere Reserve, Sri Lanka. This is very close to our Western Ghats flora because geologically they were together. Next slide, please. This is maintained by University of Peradeniya, Sri Lanka. Their teams used to interact with other teams frequently when we meet in conferences. Now, here is the total picture of, ever since started their research in the mid-70s, they compiled the data as of then and tried to look at what is the current scenario with respect to global environmental changes. And here is the summary of it. The core results reveal that from various plots, rates of tree mortality, tree death, have been increasing in many of the world's tropical forests as a result of climate change and many other global change drivers, including habitat fragmentation and altered atmospheric chemistry. When you talk about altered atmospheric chemistry, how much is being altered? Here we have the data. Since 1981, atmospheric CO2 increased by 16%, monitored in the world's first 50-hectare permanent research plot, Barra Colorado Island, Panama. Temperature warmed up by 0.6 degrees Celsius in the site. The forest around the 50-hectare plot experienced 30% change in precipitation. Landscape around the plot experienced deforestation. These are summarized pictures from various CTFS plots. Next slide. This is an ongoing program, and we have this LTER network, long-term ecological research network, ever since started, supported also by National Science Foundation USA. And here are additional few more long-term research sites. And before this 1975 permanent research plots established, there have been a number of research stations. Earlier they were called so. very familiar way back from the 1800, mid 1800 onward. We get to have to our Madras University when I was a scholar in Center for Advanced Study in Botany. We used to get to research bulletins of such long-term research plots like Hubbard Brook long-term research. This was called Hubbard Brook Experimental Station. Then the other for agricultural science, various programs, the famous Rothamsted Research, now called earlier Rothamsted Experimental Station, UK. The Georgia Coastal Ecosystems LTER, Howard Forest LTER, Florida Coastal Program, Konza Prairie for the temperate grasslands, Kellogg Biological Station, and one of the premier such programs is on a long-term basis happening is the Luquillo Experimental Station in Puerto Rico. So, and many more. So in addition, you have what is called as a Fraser Experimental Station. Fraser, Hubbard Brook, Rothamsted, Luquillo. These are some of the very old research stations wherein people have started their long-term programs at the institutional scale, and several institutions have later joined them. Initially, to start with, they were the efforts of few people, but later many institutes joined. That way, we have the platform set to work on various aspects of science and related branches too, including livelihood and up down to culture they have. So in world's LTER or forest geo programs, and equally we have, I'll be talking about later on the for the marine systems, marine geo program. So these have helped us a lot in understanding science and how systems are responding to the changes that are happening. Next slide, please. So you can always log on to any of these. LTR, when you type out, you'll get to know the details, world's LTR programs, what programs are there and how research is progressing, and in particular, publications. So wonderful publications that are the outcome of long-term research, and it's like a chain reaction, and one gets a good idea about what is happening with respect to those systems over a longer period of time contributed by teams of scientists. Next slide, please. So I'm not talking in detail about many of these sites, and you can log on to those sites because of the time constraint. I'm just taking a glimpse. I'm just providing glimpses from a few long-term plots. Here we have is Luquillo Experimental Forest located in the Luquillo Mountains, eastern Puerto Rico. So it's one of the largest scale plots, and what have been important is in those regions, the hurricanes. So over 30 years data and how tropical forests are responding to such natural as well as human disturbances. So hurricane frequency impacts forest biodiversity and ecosystem functioning. Climate change will impact lower elevation forests first. Drought in rainforests is increasing in a warming world. A study in 2018 compared biomass of animals collected in the forest with data from the previous figures and found a large decline, which the authors could attribute to global warming event. Next slide, please. We'll see the Indian scenario and our programs in due course. Next, please. Okay. So here are some of the compilations, and this is what I'm taking. I told about a number of publications, 100+ publications you will see from each and every one of these long-term research programs. And here I'm just selecting one from Proceedings of the National Academy of Sciences, USA, PNAS. Climate-driven decline in arthropod abundance, how it restructures rainforest food web. Okay, so arthropod and insectivore abundance data between 1976 and 2012 at 2 mid-elevation habitat in Puerto Rico's Liquillo rainforest. So temperature during this time risen by 2 degrees Celsius. Using the same study area and methods employed in the 70s by Listserv. So, and that is being used to compare, and by same methodology followed, and you will see 4 to 8 times and 30 to 60 times sticky straps. Now, how much changes that are happening, and analysis of such data over a long period would give us an idea about how systems are responding with respect to climate change, and how in turn, as we all know that systems are interconnected, and understanding intersystem coupling in ecological research is quite a tough task even to ecologists, but that is what we are trying to put in our effort through multidimensional and multi-biota studies to understand such interconnections of biota and how system functioning is in turn interconnected, and overall changes with respect to time. So with respect to various ecological functions. Okay, next please. The trends could be predicted that way. Next slide, please. Briefing about Hubbard Brook Experimental Forest, 7,800 acre hardwood forest. Okay, the non-coniferous forest. Hardwood is temperate deciduous species. Okay, how systems are responding to such changes ever since founded in 1963. We used to get their bulletins when we were in Madras University. So a comprehensive ecosystem studies in a very collaborative manner, multidisciplinary in nature, such long-term research studies focusing on many biota. So research focus there is with respect to ecosystem response and forest, how they are changing with respect to geophysical phenomena and the response of biotic components, thus trying to understand the overall forest functioning process. So one can log on to individual research programs, and the publications arose out of such programs. Next slide, please. Those who are interested on the agricultural side, please log on to Rothamsted Research. Earlier, it was Rothamsted Experimental Station. I am not going to the details of it. I'm not projecting many of the permanent programs here for want of time. Just few to exemplify, I am projecting. The Fraser Experimental Station, Colorado. 308 hectare research facility established way back in 1937. So it's almost a century like. So their intent being to study timber, water, wildlife management, their integration in the high elevation subalpine coniferous forests or the temperate needle-leaved forests of the world. It's one of the few studies in the Rocky Mountains wherein you have long-term records on hydrology, climate, forest structure, growth, and responses to forest management. So ever since 1937. So these are not easy jobs to maintain and sustenance of such studies with the teams of people. Next slide, please. Those who are interested, kindly log on to those programs. Coming to the tropical world, besides BCI that we have seen a 50-hectare plot, deforestation has been going on, and to what extent that might affect forest biodiversity, and what could be the minimum size of the forest reserve that needs to be protected to have the life form biodiversity maintained and ecosystem services continually obtained. To address these questions, way back in the 70s, Biological Dynamics Forest Fragmentation Project, BDFFP, to study the effects of habitat fragmentation on tropical rainforest was initiated in Brazil, now maintained by Amazon Biodiversity Center. Now the current name, you can type on Amazon Biodiversity Center, alternatively BDFFP, founded in 1979 by renowned conservation biologist Lovejoy. Okay, so it is one of the longest running programs and largest scale on forest fragmentation study. So, and the data suggests that even small fragments can be of considerable help to maintain floristic composition and carbon storage after experiencing even dramatic changes, and it takes centuries for system to revert back to the original conditions. And Dr. Lawrence has been involved in that. He visited us sometime back in Pondicherry University, and he has been analyzing deforestation and its impacts over a long period of time. So large-scale inventories of species responses fragmentation, which is a main focal point of research concerning future conservation of biodiversity. And we do not have at the species level many studies available because these are very cost intensive studies. Next slide, please. As I told you, colleagues, I'm just providing a glimpse of these. The Indian scenario, there have been efforts taken. Now it is being supported by Ministry of Environment, Forests and Climate Change, establishing forest observational plots, okay, long-term plots. And this is just being summarized in this research paper by Tiwari et al. So they have used several, how many such plots, what are traditionally called linear tree increment or LTI plots maintained by Forest Department, and such programs taken forward for establishing various newer programs, like we have Forest Geo in the other parts of the world. So we have long-term ecological observatories initiated with the effort of Ministry of Environment, Forests and Climate Change. Next slide, please. So one can log on to those. So this was our long-term dream, that to establish such a long-term research plot in the hottest biodiversity hotspot, one of the 8 in the world, being Western Ghats, Sri Lanka. So we chose, after a very long exploratory visits in various locations of peninsular India, we thought one of the ideal sites could be the Anamalai Tiger Reserve, in which we could get contiguous 30-hectare LTR plots, and short-term monitoring could be also made. So, and next slide. This is located in Varagalaya, 23 kilometers from the Anamalai station, and you have relatively undisturbed forest. And this is on the tree diversity publication in the journal Biodiversity and Conservation. Dr. Ayyappan is now in the French Institute of Pondicherry. He is now involved, along with our present scholar, on various ICFRA funded permanent plot programs in India. Next slide, please, wherein we are currently involved with in the Central Western Ghats. So in the Colli Hills, in 4 shallow forests, we have 2 hectares in each of the 4 shallow forests. Although Eastern Ghats tree diversity is almost half that of the Western Ghats, but these forests are of considerable importance in the much fragmented Eastern Ghats region of peninsular India. This is one of the panoramic view of the Colli Hills in the Eastern Ghats, when we have 4 2-hectare LTR plots that formed 2 major programs of research, including short-term dynamics, growth, recruitment followed up. Next slide, please. Well, On the Coromandel, besides the Western Ghats, Eastern Ghats, and on the Coromandel coast of India, so we have since 1989, when we were in the initial stage, moved to Pondicherry University's main campus. So we thought that these are very ideal sites, hitherto not much addressed by scientists from ecological intensive research, and that gave us a great opportunity. And there are a total of about 1,000 such sites on the east coast of India, around Tamil Nadu, Puducherry areas. About in Viluppuram, Kadalur, Puducherry districts, about 500 of them, and surrounding Pudukkottai district, Arantanki routes, about 500 of them. These are pockets of forests, fortunately protected on the religious belief of the local people, under the forest type tropical dry evergreen forest, one of the important highly productive forests on along the east coast of India. This is one of the sites close 20 kilometers on the ECR from Pondicherry University, so Urani site. And we have initiated research in 2001 here, but the other sites are much older, way back in 1992. I'll be showing the details of 30 years of research in these forests from the permanent research. Next slide, please. It's just a view of these forests. A sectional view of tropical dry evergreen forest in a site 15 kilometers from the coastal town Kadalur, or about 40 km from Pondicherry University, south of it. So these are one of the most productive forests in the world, with high forest production, as we quantified for 2 years litter production, and one of the world's liana dense forests, in fact, third world's woody climber dense forests, next one only to the Bolivian forests of South America and the tropical African forest. Third, liana dense and one of the highly productive tropical forest ecosystems on the east coast of India. This is a site called Kulandikuppam. We abbreviated with the code KK. Next slide, please. So these are our permanent research sites, and the tree, you can see the trees are tagged with the sequentially numbered aluminum tags, which can remain for several decades. And this is how we, we mark the point of measurement for remeasuring at a later stage to determine growth and how many trees have died and how many got newly recruited and they are given new tags. We follow a particular series of tags. A 20,000 series is followed here. So this is how permanently tagged individual subtrees in the permanent research plots help us a lot to understand the level of biodiversity for us to determine at a later context at, say, 5-year, 3-year, or decadal interval to determine forest growth, recruitment, mortality, and how systems are responding with respect to various conditions. Now, ever since we established, we had other cyclones, so Thani, Vardha, whatnot. So many of these, the impact of these on the tree biology and ecology. Next slide, please. These are some of the important species. Do not worry about the details of this work, but I just summarize how much change has happened over a decade and 2 decades in various sites. We have a total of about 27 sites. And in few sites, data are summarized here. In the first sector growth that you see net change in the 2 decades, loss of to 863 species, about 30% of the trees lost. 30% of the trees lost in the 10-year period in one of the sites, 2007 to 17. So that is a heavy loss in such forests. So in 2 sites, we have given how tree density has been reduced. tree density has been reduced. So that being the nature of changes that are happening cumulatively due to natural as well as anthropogenic impacts in various sites, the changes are shown here and the publications are referred here. Next slide, please. One can request the reprints if you wish, and Dr. Tarun will have my mail ID, so please feel free to ask for. That work is published in the journal Geology, Ecology and Landscape from Taylor and Francis, Cambridge. Two scholars worked, and one from Odisha and one from AP. So this talks about how much decadal change into Indian tropical dry rainforests at the 10-year level. See, tree biomass and carbon stock declined by 42% in much disturbed site, and just by 9% increased in undisturbed site. See, when sites remain undisturbed, okay, that means that there is greater human impact that is happening than due to climate change. If it is climate change, the loss should be equal in both. So disturbed sites suffer a lot because they are being continuously disturbed. Undisturbed sites, we have a record of increase in biomass and carbon stock as well. Next, please. I'm trying to speed up a little. In the other two sites close to Pondicherry University, 6 and 20 km. So we have data from 1992. Next slide, please. So from 1992, here is our student Dilshad from Malappuram who worked on the how much in 3-decade change, 1992, so and then 2002, 2012, then 2022, we are 21 we are to do, but the guy was interested. We thought we could initiate the work. Fortunately, before lockdown started, they just completed the study. What a fortunate opportunity for these people to work on these permanent Indian tropical dry evergreen forest plot. So, and next slide, you will see the results of such changes. Next, please. I'll go a little faster. Next, please. So how much of change? I draw your attention to the last but one column here. Say 92,329 stems. 2002 slight increase, then drastic decline because of the cyclones, Thane, so that has drastically affected